This video is going to cover Unit 29, Section 4, lateral areas and surface areas of regular pyramids and right circular cones. Okay, so the formula for the lateral area of a pyramid or a cone is the lateral area is equal to the perimeter of the base times the slant height, we'll get to that in a moment, divided by 2. For a cone, it would be the lateral area is equal to the circumference of the base, which is the same thing as the perimeter, times the height slant divided by 2. So what is the slant height or the height slant? That is, if you look at this pyramid right here, this is the slant height from here, from the vertex, all the way down to the edge. It is the height of one of the lateral sides. For a cone, it's the same kind of thing. So you've got from the edge of the circumference all the way up to the vertex, that is the slant height. This would also be a slant height from here to here, and then from here to here as well, for a cone, but not for a pyramid. The slant height goes from here to here. So how do we calculate what the slant height is? Well, let's take a look at this pyramid, and let's say that we've got our height coming down. And let's say this side right here is 10, and the height is 12 on this one. Okay? This side right here doesn't matter for the slant height. Now what I'm going to do is I'm going to take this cone and I'm going to turn it to the right a little bit, and I'm going to look at the cross section of it. So coming down, the height right here, then this base right here, which is 10, and then this is coming down like this, just forming a right. So what we have here is, this is a right triangle. Both of these are right triangles. It doesn't matter which one we're looking at. Let's take a look at the one on the right. This height right here I know as 12, and the distance from here to here is half of this distance right here, which is 5. Now to find this height slant right here, I use the Pythagorean theorem. So the height slant is equal to 12 squared plus 5 squared, and then the square root of that. So the square root of 144 plus 25, let's do that. So we've got the square root 144 plus 25 is equal. Wow. I just made those numbers up, and that came out to be a nice, neat, even 13. So that height slant is 13. Okay? Now, to finish this, I need to know what this side is right here, and let's call that 8. So this is a rectangle, not a square. So the perimeter of the base would be 10 plus 8 plus 10 plus 8. So 20 plus 16, 36. So the perimeter of the base is 36. So I will say 36 times the height slant, which is 13, divided by 2. So that is going to give us the lateral area of that pyramid right there. So 36 times 13 divided by 2, 234. 234, and we'll just call it inches. It doesn't matter what the units are right now. Now, to find the surface area, I have the lateral area. So surface area is going to be lateral area plus the base area. Well, the base area here is 10 times 8, which is 80. So we'll just add 80 to that. Now this is the lateral area right here. And then once I add these, I will have the entire surface area. So 234 plus 80, 314. So the surface area of that figure is 314. And the cone would be the same thing, except for this would be a circumference instead of the perimeter. You would find the slant height the same way by turning the cone sideways, and it would look the same as this. And then you would just take the radius would be this distance right here, unless they give you the diameter, and then you have to cut that in half. Well, let's take a look at number 14 on page 727, number 14. So you've got figure 2930. Okay, we got all the dimensions there that we need with the exception of the slant height. We'd have to figure that out. And what they want is, so let's go ahead and get a somewhat clean sheet of paper here. Ignore that, that's a failure. Okay, so 811, edit. So we have a height of 19 7/8 inches. We have a diameter of 28 5/16 inches. So these are both in inches. Now that's enough information. Now what I'm going to do is I'm going to look at the side of the cone. So I'm going to put it on its side. So this is the diameter from here to here. Oops, that doesn't look really good. This is the height, which is 19 7/8 inches. So what I need to find is I need to find this distance right here. So I cut this in half. So 28 divided by 2 is 14. I just need to know the decimal. 5/16. 5 divided by 16 is 0.3125. Divide that by 2. And I have 14.156. That's far enough. So that's that distance. And then that distance right there goes there. Let's get a decimal of that. 7. So that distance is 19.875. So to find the slant height here, I say is equal to 14.156 squared plus 19.875 squared, and then take the square root of all that. Don't think it's going to work out nice and neat this time. 14.156 squared plus 19.875 squared. Not bad. So the height slant is 24.4. Now what I need to do is put that into the equation for the lateral area. This does not have a base, okay? So this is just sheet metal wrapped in, or actually it's sheet copper. It's not metal, it's copper. Well, copper is a metal, but it's not steel, it's copper. Wrapped into a cone. There's no base on this. So all we need is the lateral area. And that is equal to perimeter of the base times the height slant divided by 2. So what I need to find is the perimeter of the base, which is the circumference, and circumference is equal to diameter times pi. So what we have here is .3 is good enough, times 3.14. 28.3 times 3.14 is equal to that. So that is the circumference. So that's the perimeter of the base. Now we need to multiply that times 24.4. That's 2,000. Now divide by 2. I could have done this all at one shot, but I had it going. So that is okay. So this is the lateral area. Okay, we had some technical difficulties there. So where we left off was we had a lateral area of 1,084.1 inches squared. Now, two things I need to do to this number before we can move on. It says that in part A, it says allow for 5% for the overlap. Okay? So what I need to do is I need to add 5% to this. So one thing I could do is I could multiply this number by 0.05, and then whatever I get there, I add it back to that, or I can take this and multiply it by 1.05, where the 1 is the original number added back to it. So 1084.1 times 1.05 gives me, now I have 0.3 inches cubed. Or, oh, nope, not cubed, squared. I'm not going to edit that out. That's squared. Okay, now, part B says find the weight of the cover. The sheet copper used weighs 2.65 pounds, 2.65 pounds per for every 1 foot squared. Well, wait a minute now. I've got inches squared. So how do I convert inches squared into feet squared? So let's go ahead and figure out how we do that. So let's write it down here. If I have 1 foot right there, I hope everybody knows that there's 12 inches in a foot. This is linear, so 1 foot is 12 inches. Now if I go square with that, if I got another foot right there, that's another 12 inches. So this is square. So 12 times 12, which is 144. So there's 144 square inches for every square foot. So I take this, and I'm going to go ahead and convert this into, so I've got feet squared here and inches squared here. The feet and the feet will cancel. So 1 square foot is 144 square inches. So what this is going to tell me is how much weight it is per square inch. So if I multiply across the top and across the bottom, I get 2.65 divided by 144, and I have 0.0184 pounds per square inch. So now I just multiply that by how many square inches I have. Now another way to do this would have been to go ahead and convert this into square feet, then just simply multiply it by 2.65. I'll try it that way too, just to make sure we get the same number. So 1138.3 times 0.0184, and I get about 21 pounds. Okay, so let's try it the other way. So let's see. I don't have any room on here to do what I want to do, so I will grab this sheet of paper which has some room on it. Ignore all this junk. This is out. Okay, so I have 1138.3 inches squared. And I want to put a 1 under there. And now I need inches squared in the bottom and feet squared in the top. And 1 foot is 144 square inches. So this is going to get me the square feet of that. And then I just multiply it by 2.65. So 1138.3 divided by 144. So this object is 7.9. What did I say? 7.9 feet squared. Then I multiply that by 2.65. 7.9 times 2.65. is 21. So yes, 21 pounds. So either way I did it. So the first way I did it, I took and converted this from 2.6 pounds per square foot into 0.0184 pounds per square inch. Then I took this number and I multiplied it by that to get 21 pounds overall. The second way I did it was first converting my square inches into square feet, which was 7.9 square feet. Then I just multiplied that by the 2.65 and I still got 21 pounds. Okay?